What asteroids are really remnants from when the solar system was forming.
Comets and asteroids retain the secrets of the formation of our planets. Exploring comets and asteroids will tell us how life developed on our planet.
We also have to respect them as something that could actually change our way of life even today. We have high confidence that the dinosaurs were ended by a very large impact of asteroid on the Earth. If a large enough asteroid were to hit the Earth, it would be quite cataclysmic.
Impacts are not necessarily just bad things. The Earth was very dry when it formed. There was hardly any water, there was hardly any carbon. And we think most of the ingredients for life were delivered by asteroids and comets.
You could spend the rest of your life exploring every little part of the comet, not see the same type of thing twice.
Ten, 9, 8, 7, 6, 5.
So the NEAR mission was designed and conceived so that it would actually show up at an asteroid stop, be in close proximity to it for an extended period of time.
1.
Just to see what an asteroid was like.
0 and liftoff.
NEAR launched in 1996.
Chamber pressure rising in all 6 chocolate motors.
And like all planetary missions, it takes a long time to reach the target.
Good chamber pressure on the main engine.
So it didn't arrive at Eros until the 20th of December in 1998.
We have a good engine control in the main engine, good engine control in the verniers.
As you fly into the body, you've never seen it before, and you start to see the images. At first, they're very fuzzy, but then they come more and more into focus. And at every stage, you're seeing new things. It looks like it's two asteroids that are just sort of resting on each other. And it's got this beautiful saddle regions where they sort of touch each other.
That phase of the mission lasted from December 1998 all the way to February 2001. The spacecraft was nearing the end of its life. It couldn't fly back to Earth.
The mission manager had people start studying, well, what would it take to actually bring the spacecraft down to the surface to have a soft landing so that maybe the spacecraft could even survive? When it was launched, it was never designed to actually land on the surface.
I remember thinking that there's no way this is going to work.
We have successfully deorbited around Eros, and we're on our way down. There's no turning back now.
It was a complete success. It landed, perched itself on the surface. It was quite exciting.
This is the first time that any spacecraft has landed on a small body.
NEAR Shoemaker showed that it's possible to touch down on an asteroid. The next big target is to bring a piece back to Earth.
Got it? No. It dropped. See if you can pick it up again. I think it'll fit in the bag, Jim.
When we went to the moon, we got lunar rocks, then brought them back to the Earth, and have been analyzing them ever since. It allows us to understand our own Earth so much better. It's sort of like archaeology of the solar system.
6, 5, 4.
So Hayabusa set the stage to answer that next question.
Main engine ignition.
SRB 点火、リフトオン。
SRB ignition and liftoff.
近星探査機。
JAXA, the Japanese Space Agency, wanted to send a spacecraft to an asteroid, grab a piece, and bring it back to Earth. The very first sample return mission.
That was really the first time. They were the pioneers to try something. So you really have many, many, many unknowns. Which is crazy.
It was a very ambitious mission. From the start, it was also sort of a cursed mission.
There was a very big solar flare. It hit the solar paddle of Hayabusa.
The solar flare compromised their solar arrays, so they had less power to push themselves on towards the asteroid. Furthermore, they were carrying some reaction wheels.
Reaction wheels are used to stabilize the satellite, and one of them was damaged.
That was also a very large complication because it changed the whole way that they controlled the spacecraft.
Space is hard. It's not a friendly environment. When everything goes well, it's a miracle, especially when you go to a new world. It took 2 years for Hayabusa 1 to reach Itokawa. The first image started to come.
Hayabusa 1 is there to collect pieces of the asteroid, and that all begins on November the 5th, 2005.
The spacecraft went down to the surface.
The spacecraft's going to slowly come down towards the surface, and then they have a funnel, and that funnel touches down on the surface. It would fire a projectile into the surface, and the debris comes up the funnel and is then collected into the container. And then away it would go. So it was a touch and go.
The dangerous thing is the surface temperature can destroy the spacecraft.
There was evidence that the projectile was not fired.
So there was nothing to make that plume of dust go up into the sample container. Eventually the spacecraft leaves the surface, and unfortunately there is now a leak in one of the fuel lines.
There was a leak which generated a torque, so the spacecraft was really mad.
When you're leaking material into space, it's like having another engine. It's like a jet.
We had a very serious problems. We couldn't control the spacecraft. What can we do? We never gave up. Every time we were able to find some solution to overcome troubles.
They were able to tell that in a few months, they would actually be able to get small commands into one of the antennas.
Finally, we found how to operate the spacecraft. At that time, we are very happy.
For Hayabusa, the struggles were not over, so it had to get back to Earth.
Here is this crippled spacecraft, literally limping home.
People are worried that the mission is going to fail at this stage, that we potentially may or may not have collected samples, and that it might not actually make it back to Earth.
So they're hanging on by a thread.
For Hayabusa, the struggles were not over. It had to get back to Earth.
So they're hanging on by a thread. But they were able to hang on.
Re-entry vehicle looks like lower right.
They were able to successfully navigate all the way back to Earth.
Nice flashes. Oh, wow.
The capsule landed, but maybe empty. Nobody knew. All these efforts maybe was for nothing.
They have indeed collected maybe 1,500 dust particles.
The scene was quite emotional. I was very moved to see the sample.
Hayabusa came back in 2010. We still do fundamental discoveries with these teeny samples.
One of the things we're interested with asteroids is whether they delivered the oceans to Earth.
So a few weeks ago, there was a measurement of the water properties of the sample. They measured the properties, and it's the same as the property of the oceans on Earth. It's the same kind of water.
They are a match. So it's the first clue that maybe all this wonderful water on the surface of the Earth actually comes from asteroids. Asteroids are fascinating, but further out away from the young sun is where very bizarre objects were created, the comets.
Comets are the most primitive objects we can study. What is, so to say, the source of this wonderful display in the sky?
People have always been intrigued by these messengers that come out of the night sky. What are these objects? Where do they come from? What are they made of? What's locked up as treasure, as secrets in comets?
For a long time, they were mysterious. We didn't even know their orbits. And it really wasn't until the observations of Halley's Comet, where it was realized that they actually orbit the solar system, that it comes back every 76 years. Halley's Comet has a special place. 1986 was a really special year because we got our first look.
It's a once-in-a-lifetime opportunity.
First stage servo motor started.
The objective of Giotto was pretty simple, really, to intercept Halley.
Final arming, ready to go.
This was the excitement, because this is new. This was an adventure never done before, and now we go.
Ignition. Ariane first stage ignition and takeoff.
We launched early July in '85, so it's an 8-month journey.
First stage flight. Début des manœuvres de route.
The comet has an atmosphere that we call the coma, and then the tail streams away from the comet. And the tail also contains dust. Dust particles, although they might not seem hazardous, if you fire them at a spacecraft at many kilometers per second, even a small dust particle can destroy the spacecraft. Giotto made its rush towards Halley's Comet, and it's getting closer and closer to the nucleus. And it's being hit by particles. They're picking up impacts.
Dust impacts were increasing. It's a tense time. Just before the actual encounter,
it gets hit by a big one. And it puts the spacecraft into a spin. And so all of a sudden, its protection, its shield, is not facing the dust particles.
We got anxious because we couldn't do anything. We tried to keep cool and quiet and see what happened. All of a sudden, images stopped.
Giotto made its rush towards Halley's Comet, and it's getting closer and closer to the nucleus. It gets hit by a big one.
All of a sudden, images stopped.
The camera goes dead. And the spacecraft is still flying through that debris. And I think there were a lot of people there who thought that they were going to lose the spacecraft, and that was it. That was the end of the mission. But thankfully, it survived. It went all the way through and lived on.
And it took about a couple of minutes till we received all the data. First of all, you see the image. And you are one of the first ones to see a comet nucleus. It's beautiful.
They were just truly incredible. The comet, surprisingly, is not this bright, clean ball of ice. It's dark. It's almost black.
It was active only in a few spots. That was the first big surprise, because we thought the nucleus would be active all over the surface.
We've learned about processes that are going on inside a comet that we would have never have guessed unless we'd gone there. Giotto was remarkable.
When Giotto flew past Comet Halley in 1986, the flyby was around 68, 70 kilometers a second. You see it for a few minutes and then it's gone. It's all over. To learn more, you want to go and rendezvous with the comet. You want to fly alongside it. Can we learn about the evolution of these objects by studying it over time? And of course, then the idea comes up, you would want to touch down on the surface. You want to land there, sample material.
To do all of that in one mission is incredibly gutsy.
10, 9, 8, 7.
The first time I heard about the mission, I thought they must be joking.
5.
The Rosetta mission was incredibly ambitious,
top.
but we jumped on it.
Décollage.
We launched in March 2004. The whole travel to the comet was an adventure for Rosetta. The comet is on an orbit with a different energy level compared to the one of the Earth, so we had to actually impart this energy to our spacecraft to get to the same orbit.
So we did this thing to use the planets and to use their gravity to slingshot us through space on a different trajectory with more speed in order to be able to get to the comet.
We were really launched very fast, but getting very far from the sun. We could not keep all the systems on board active because the illumination of our solar panels was getting very weak.
So the decision was made, in fact, to turn it off.
I hated that concept from the very beginning. I've been fighting it for years. I was convinced we would never do it. It was too crazy. Switching off the radio signal is like cutting a vital link.
You've been flying a spacecraft for 7 years. It's at hundreds of millions of kilometers away. And what do? You send a command to switch it off and wake it up 3 years later. It just doesn't make sense. And this is what we did.
We spent 2.5 years without contact. And we waited.
We couldn't talk to it while it was in hibernation. We needed it to wake up. which it was due to do on the 20th of January 2014.
We were sitting all in the control room, waiting for the signal to come. And this was probably the most tense moment of the mission. This was everything or nothing. It was life or death.
It was building up tension at that stage. Why is not coming?
It was very difficult to bear. We started really getting worried.
Have we lost the mission?
5, 4.
The Rosetta mission was incredibly ambitious.
Top.
To do all of that in one mission is incredibly gutsy.
We couldn't talk to it while it was in hibernation. We needed it to wake up, which it was due to do on the 20th of January 2014.
It was building up tension at that stage. Why is not coming?
Then suddenly, the signal came.
When the signal came, it was a big relief for me personally. There was an explosion of joy.
A little blip on a noise spectrum told us Rosetta was there and it was calling home.
We made it. Yes. That's a big success for everybody.
We have it. We're ready. We now have the spacecraft back. We can go and do the rest of this mission and finally get to the comet.
But now the mission starts, because now we have to get to the comet, fly around the comet, orbit the comet, and land on the comet, all within the next 10 months.
Rosetta took 10 years from launch till we finally got to the target that we were going to study.
The comet we ended up deciding to go to with 67P Churyumov-Gerasimenko.
At the beginning, the comet was just a very small dot. And then day by day, the comet was growing in the field of view of the camera.
We saw this incredible shape. Some people have described it as a rubber duck.
Comet 67P is about 4 kilometers in size. If you were standing on the bottom of the comet, you might see a flat, dusty plain. If you were standing on the head of the comet, it might look more rocky. If you were standing on the neck of the comet, you would be in this interesting valley, kilometer-high cliffs on either side, and running along the neck between your legs is a huge crack. There's so many different types of surfaces and variety. You could spend the rest of your life exploring every little part of the comet and not see the same type of thing twice.
The first thing I thought was, we're never gonna land on that thing.
It was the morning of the 12th of November, 2004. It was excitement, but also tension for the upcoming events.
Great news, we are go from the lander. The commands have already been sent. Now we just have to wait for separation.
Rosetta just pushed very gently away. It was like pushing it really like this. 18 centimeters per second is nothing, like this. The fall lasted 7 hours. They could get the images of Philae getting closer to the surface during the descent.
As we got closer and closer, the tension began to rise.
I was looking at the data coming from Philae. I wanted Philae to survive the landing. So I was just staring at the screen, seeing this data coming.
We actually saw several subsystems activating.
We got the information that it had reached the surface.
We definitely confirmed that the lander is on the surface, and I leave it to Stefan. I think it's up to him to judge how it's going now on the lander.
We were in a major success. We had landed on a comet.
This was the moment of the mission. This was a huge success.
We are sitting on the surface. Philae is talking to us. More data to come.
Philae started taking pictures, taking measurements, doing its jobs. I'm on the surface, yeah? I touched down.
Yes, it had touched down on the surface, but it hadn't stopped moving.
It's the redundant one. The
nominal one,
nominal
is 1385.
It took us 10 to 15 minutes to realize that something was wrong.
This one is not going down, though.
The lander, the elevation did not go down.
It's the same resolution as...
It's probably due to...
We realized that the radio signal was not stable. It couldn't have been on the surface. It was definitely lifted up and flying again.
Yeah, otherwise it would bounce. If it would have bounced.
I said, it's not possible, cannot be.
Quite quickly, people began to realize that we must have bounced.
It bounced, it had a very long travel.
And then it hit the edge of a cliff, started tumbling.
We were scared to death. We were in a major success. We had landed on a comet. It took us 10 to 15 minutes to realize that something was wrong.
This one is not going down, though.
It hit the edge of a cliff, started tumbling.
We were scared to death. My fear was we are going to lose the contact now. And if we lose the contact, that's it. This is the end of the mission of Philae.
And then finally, after 2 hours, it touched down in a very dark place.
Then, half an hour later, the signal was abruptly interrupted, and Philae wouldn't transmit anymore. We haven't the faintest idea when the signal would come back. When I came in the morning, we see alarms coming into the control system, and it's the signal of Philae. This little baby has been surviving on the surface of the comet. So we started receiving data. Guess what we get? The first image of the surface of the comet here, real time. We saw it real time coming here. This is just fantastic. It's something that happens once in our life. You see the surface of the comet, you see a portion of the leg, and you have the feeling that there is something odd. Indeed, we found fillet that was tilted on its side, but it was just the surface of the comet.
The images came back, and it was then that we realized that we were in this place that was almost completely shady.
It was in a dark area, so it would have not had the chance to recharge the batteries.
We knew then that we were going to run out of power after 3 days.
The whole 3 days on the comet were certainly 3 of the most incredible days of my life. When you see the images, you get this very strong feeling you are on a completely new world. You are seeing a new world for the first time. The formations were really totally unexpected. Fractal geometries, ruptures everywhere at every dimension, from millimeters to centimeters. It gives you the impression of how this surface suffers the extreme variation of temperatures by getting close to the sun and then back away. It's a continual thermal stress. After 3 days, it was Friday afternoon, it was clear that the battery was getting to the end.
You could see fillet fading out during the night, during the last contact. But if we look carefully, the bulk of the scientific mission of Rosetta still had to come, because we flew there to follow the comet in its orbit around the sun. The comet's getting close to the sun, its activity increased significantly.
We could really see how the surface is completely revolutioned by the sun. There were explosions. Holes observed in the surface with an underground structure which is still today totally unexplained. There were landslides that we have observed.
You could see jets, gas jets, fountains coming out of the comet. You could see actually like snowstorms going around the comet.
So on Rosetta, we had a dozen instruments, and not all of these instruments take pictures. They get data in different ways, such as the spectrum or measuring molecules. It's squiggly line data. And those squiggly line data can sometimes have much more information than the pictures do.
The Rosina instrument found that there is a molecular oxygen trapped into the nucleus of the comet. Molecular oxygen couldn't have survived the formation of the solar system. Therefore, it means that it was inside the nucleus of the comet before the formation of the solar system.
We were able to see molecules, some of which had never been seen before. For instance, glycine, the amino acid, a building block of life.
And if the oxygen was trapped in the nucleus before the formation of the solar system, then also the amino acids were trapped there. If these two things, which are the ingredients of life, were trapped there before the formation of the solar system, they are not specific to our solar system, so the likelihood that life has formed somewhere else as well.
So on Rosetta, we had a dozen instruments, and not all of these instruments take pictures. They get data in different ways. We were able to see molecules, some of which had never been seen before. For instance, glycine, the amino acid, a building block of life.
There's all the material in there that you need if you want to produce life.
This confirmation is very important because it shows that comets could have been the objects that brought the components of life onto Earth.
As we had been with the comet for more than 2 years, we were moving back out again away from the sun.
The mission had accomplished all the results. Nobody had thought about how to finish the mission.
Shall we hibernate again, taking the risk of a much longer hibernation? Shall we switch it off in September? That's it. Bye-bye, Rosetta. Then we proposed to land with a mothership on the comet. It was not designed for landing, but this was taken as a good idea because this would allow us to observe and measure the last few kilometers where we had never been.
The decision was indeed taken to say, let's go down, let's do it.
And so we got closer and closer, getting more and more detailed images than we had ever had before.
Only a few days before the end of the mission.
Right there at the edge of the image was a shape.
We could see there in a sort of crack in between some rocks on the comet, in shadow. Finally, we got a picture of Philae on the surface of the comet.
Good morning, morgen, bonjour, et bienvenue, welcome for Rosetta's grand finale. We are here live in Rosetta control room at ESOC in Germany.
So by this point in September, we had planned to put Rosetta down onto the comet.
It is a special day today. The European Space Agency's comet-chasing Rosetta mission is coming to an end. It will be the end of a mission that lasted 4,595 days in space.
Everything we had put into this, in terms of the human story, but the science, this several decade-long effort was coming to an end, and we were choosing to do it. And even sitting here now, several years later, I mean, it brings back those emotions.
We commanded the spacecraft to do the final plunge down to the surface of the comet.
The spacecraft is taking images during the descent.
We could see some of the images, and we could see the surface coming closer and closer, and time passing by, and we knew that the mission was coming to an end.
It got closer and closer, till finally we lost contact. And that was the end of Rosetta.
When the signal shut down on that day, people were shell-shocked. I mean, even though they knew it was coming. But I remember walking around the corridors, people just leaning up against walls, just staring into the distance. It was, yeah, I mean, it's something those of us who are involved will never forget.
It was quite an adventure.
Our understanding of how asteroids and comets might contribute to our existence. We know the kind of rocks that appear on their surface. We know the minerals in those rocks. We know about the organic molecules. We know about the water. None of these things we would have learned by looking at asteroids and comets from a distance.
Each time we further our knowledge, we get a little bit closer to the story of where did we come from?